Hello students. Welcome back to class. Today, we are moving into part 4 of electric fields. But before we dive in, let's take a moment to review what we learned in our previous lesson. In our last class, we discussed electromotive force, EMF, which exists even when no current is flowing. This can be observed in a cell or battery. We also talked about potential difference, which is zero when no current is flowing. This explains its effect on devices like an electric bulb. Today's objective is to explore the concept of electrolysis and Faraday's laws. Electrolysis is a process where electricity is used to cause a chemical change in a liquid. This liquid is called an electrolyte. When electricity flows through the electrolyte, ions move, causing them to either break apart or combine to form new substances. Here are the key terms in electrolysis. An electrolyte is a liquid that can conduct electricity because it contains charged particles called ions. Electrodes are metal rods that carry the electric current into the electrolyte. The anode is the positive electrode where oxidation occurs, while the cathode is the negative electrode where reduction takes place. Electrolysis is an important process in science and industry. It uses electricity to break down substances. Here's why it matters and where it's used. When we extract metals like copper from their ores, they often contain impurities. Electrolysis helps clean the metal so it becomes pure and ready for use in wires, tools, and machines. Example, purifying impure copper to pure copper using electrolysis process. Also, in electroplating. Electrolysis is used to coat cheap metals with a layer of a more valuable one, like gold, silver, or chromium. This makes things look better, last longer, and resist rust. Example, a cheap spoon can be electroplated with silver to make it shiny and more valuable. You got this. You're doing great so far, keep it up. Our second objective, Faraday's first law, tells us how much of a substance, like a metal, is deposited or liberated during electrolysis. It states that the mass, m, of a substance deposited at an electrode is directly proportional to the quantity of electricity Q that passes through the electrolyte. The formula: m is directly proportional to Q. Since Q equals I times T, m equals Z times I times T, where m equals mass of the substance deposited in grams, G. I equals current in amperes, A. T equals time in seconds, S. C equals electrochemical equivalent in grams per coulomb. Let's solve an example. Find the mass of copper deposited during electrolysis. The question is, how much copper is deposited when a current of 0.65 amperes flows for 45 minutes? We are given that the electrochemical equivalent of copper is 3.3 times 10 to the power of minus 4 grams per coulomb. We'll use the formula m equals Z times I times T, where Z is the electrochemical equivalent, I is the current, and T is time in seconds. First, let's convert the time. 45 minutes times 60 seconds is 2700 seconds. Now plug in the values. Mass equals 3.3 times 10 to the power of minus 4, multiplied by 0.65, multiplied by 2700. Multiply step by step. First, 3.3 times 10 to the minus 4, multiplied by 0.65, equals 0.000245. Then, multiply that by 2700 to get approximately 0.0579 grams. Final answer: about 0.0579 grams of copper will be deposited. Faraday's second law of electrolysis states that, when the same amount of electric charge is passed through different electrolytes, the amount of substances deposited at the electrodes is directly proportional to their chemical equivalent weights. The formula: M1 over E1 equals M2 over E2, where M1 and M2 are the masses of substances deposited. E1 and E2 are the equivalent weights of the substances. In this example, a zinc voltmeter and a gold voltmeter are connected in series in an electric circuit. After a certain period of time, 6.3 grams of zinc is deposited. We are asked to calculate the mass of gold deposited in the same duration. We are given the chemical equivalent of zinc as 32.5, and for gold, it is 197. Using Faraday's second law of electrolysis. The formula: M1 over E1 equals M2 over E2. That is, 6.3 divided by 32.5 equals X divided by 197, where X is the mass of gold deposited. To find X, we multiply both sides. X equals 197 multiplied by 6.3. Then divided by 32.5. This gives X equals 1241.1 divided by 32.5, which equals approximately 38.18 grams. So the mass of gold deposited is about 38.18 grams. Congratulations on completing this lesson. You should be proud of yourself. Put your knowledge to the test by trying these questions. They are a great way to deepen your understanding of the topic. In summary, we explored electrolysis and Faraday's laws. I hope you found the class both enlightening and engaging. In our next lesson, we will move forward with magnetic field part 1. Thank you.